Okay, so I did a little test to see if my face was in the right place and so you can hear me okay, and you can. So this is going to be the video. We're going to do about 5 minutes. So I'm probably going to overrun the first time. We're going to do like 10-minute video and then we'll see how we go from there. Hopefully my camera can hold of that. I'm going to show you the setup and everything, but I'll go straight into it first. Okay, so we're going to do a transformation. We're going to show you 4 transformations by graphing. So let me show you how I'm going to graph it. Let me flip my camera around. I realized that too strong a light means you can't see anything, so you should be able to see that okay. Let me just set my camera up 1 second. I need to put something here to hold everything in place, get my cable out of the way. Okay, that looks pretty good. Okay, you should be able to see that fine. I've got to get a pencil, one that works. Preparation is the key to success, I guess. Alright, I got a pencil, so that's not good, is it? What I really want is a thick black pencil. Oh yeah, I got a sharpener away. Like that's pretty good as a crayon. Like a kid's crayon, because I got kids. Okay, that should be fine. So we're going to use a couple of graphs here. We're going to use, first of all, we're going to use a parabola, because a parabola is really useful to see what we're doing. You can't see that very well, but you know. That looks a bit better actually. Like maybe I do a thick line. So a parabola. Yeah, you can see it a bit better. 1 second. That doesn't work. Oh, my kids are being in here, so nothing works. Oh, you can see that pretty well. Okay. So I guess we're going to do it. Okay, we'll keep going, keep rolling, right? So that's 2 minutes of the video just wasted because I would do it again and I'd start from scratch. So that's why I'm going to overrun quite a little bit. So let's see. First, we're going to do a parabola. We're going to use a parabola because it's really easy to see how it moves. Because we're going to do 4 movements on this, right? And that's a parabola. This is y equals x squared as a parabola. It's nice and simple. It's really easy. It's very easy to plot. In order to plot that thing, I have to make some x and y values. And how I'm going to do that is, first of all, I'm going to make a table like this, which has x and y values on it. And I choose the x values. So I'm going to pick some really convenient x values to use, like, well, actually, I would normally choose like 1, 2, 3, but that'll only graph half of this thing. So I really have to plot -2, -1, 0, 1, and 2. And that's good enough for our demonstration purposes. Personally, I would never do this. I'd always start like 1 and 2 because these are easy numbers. But for our demonstration purposes and how to plot something, this is fine. So -2, -1, 0. I'm going to start with 0. 0 squared. What I do is I take these values and I plug them into this equation right here. So this is the x value. So when x is equal to 0, it's 0 squared. 0 squared is 0. Let's try 1. 1 squared is 1. And let's try 2. So 2 squared is 4. Okay? And -1 squared is also 1. And -2 squared is also 4. And what I do is I plot this on graph paper, which I can't show you because my quality of my image on my video is not good enough. I'm very sorry about that. But I would have this as 1. This is 2. And then I need 1, so I plot that, that's 1, 1 right there. These are sets of coordinates, and they can be read like sets of coordinates. So that's 1, 1, that's 2, 4, that's 0, 0. 0, 0 is right here. 1, 1 is right here. 2, 4, I go along to 2, up to 4, so it's probably about there as 1, 2, 3, 4. I'm sorry about my very, very quick sketch, but you know, I have to do a video of only 5 minutes, so I have to be quick about it. So 2, 4, that's that one. And then we can plot these guys. -1 is going to be here. -2 is going to be here. That's -1, 1. -1, 1. That's -1, 1 right there. -2, 4 is going to be up here. Fantastic. So I plotted my graph. Obviously, I should do the points first and then join them up. But I showed you backwards, okay. So then I join them up like that. But you get the idea, okay? And I can plot any graph like that. So this is my original graph, and we're going to modify this guy in order to show you all the transformations. Now, if I can remember what the transformations are, by the way, that's one piece of paper. Okay, kind of bled through a bit. If I can remember what all the transformations are, what are they? I have to show you a translation. Let's see. Translation, which is a slide to the left or to the right or for up or down. That's a translation. I have to show you a stretch, which is a vertical stretch, or it's a vertical stretch or it's a horizontal stretch. I can stretch it upwards. It's actually the same as like a scale factor. I can stretch it up or squash it down. It's a stretch or a squash, really. Or I can stretch it to the left and right, or I can squash it down to left and right, really. And then I have to show you, what was the other thing? Obviously a reflection, yeah. A reflection about the x-axis, the y-axis. Now each of these components, I can do it in the x direction or the y direction. A translation in the y direction is just going to be given by f of x plus a number like 2, for example. And that'll be 2 up. I'm going to show you that right now, but let me just write them all down first. That's in the y direction. The y directions are easier. The x directions are a bit different. I don't know if I can fit it all in the video. Let's see if we can do it. It'd be interesting to show you the x ones more. That means 2 up. A stretch would be given by a multiple on the y component. So like 3 f of x, for example. That's a stretch. It's a stretch of 3 in the y direction. So it's 3 times the y. It pulls it up in the y direction 3 times as much. I'm going to show you all this visually so you can understand it. The reflection is a flip, and you can have a horizontal flip or you can have a vertical flip. And a flip is given by a negative. And negative f of x, a negative on the outside. And we're really going to look at in what direction that does it. It should reflect it vertically because it's outside the brackets, outside the parentheses. It should flip it vertically. So any y, this is the y component right here. I'll show what that means. Should be all the negatives will be positives and all the positives will be negatives. So it's actually that's a flip or reflection over the x-axis, which sounds a bit weird because we're talking about y's, but it means it flips it vertically. So let me show you each one by one. And I've got another pen here that actually works. Oh, that's pretty good. Okay, so that's what we're going to do. Let's do translation first of all. I think it'd be really cool if I could take a piece of paper and use it as a title, like that, like this. Oh, that looks pretty cool. So let's do a translation first of all. Now translation x plus 2, so we take our original line, and what's essentially going to happen is the original line, this guy is going to slide, or in this case it's going to go 2 up, so it's going to slide up by 2. Okay, I don't want to waste too much paper showing you that, sketching it twice. So I need to, this is f of x, and then we're going to change that to f of x plus 2. I guess I got a better pen. It's really difficult to find a very good pen that actually works. Okay, f of x plus 2. I also had another one which is just x. Let's try that again. So you can fit it all in there. X values, f of x values, f of x plus 2, which is a transformation. I think you need Sharpies, which are thinner. Okay, let's move this around. It doesn't have to be the best YouTube video in the world. I just realized that it doesn't have to be a good presentation. It just has to be get it done, get it done, and get it finished. So it doesn't have to be perfect. You'd have to edit anything. That's great. So these are my x values. We had them before as -2, -1, 0, 1, and 2. And what we did was we applied this to it, which was actually the x square function. So this is going to come out as 4, as 1, as 0, as 1, and 4. And then we're going to add 2 to them. So there's like this plus 2. So 6, a 3, a 2, a 3, and a 6. And we're going to go ahead and plot these two together on a graph. I'm going to squeeze it in right here. We need, like before, 0, 1, and 2, -1,-2. Okay, might be worth drawing that a bit bigger. on another piece of paper. And then we're going to plot these guys. So we need 2, 3, and 6. 0, 2, I just plotted here. 1, 3, I'm going to plot 1, 3 here. 2, 6, 2, 6, I'm going to plot here. Like this. Okay, beautiful. And then the other side is going to be negative 1, 3, negative 1, 3. And then negative 2, 6, negative 2, 6 up here. And then plot those together. Beautiful. And if you look at that in comparison to our original function, you can see it's the same thing, it's just been pushed up by 2. That's a vertical translation of 2. Okay? That's the first thing we have to demonstrate. And I've now used 10 minutes of video. And I got to do it in 5. So I got to run the same video but more, like, efficiently, succinct. I guess if I have all this stuff drawn out like that, then I could do it quicker. So the second time I run this video, I'm going to do it much quicker. Okay, the next thing we're going to do, that's the translation then. Next thing we're going to